Hi guys, Ms. Hill here talking about quadratic functions today, starting out our quadratics unit. And we're going to start working with our parent function and transformations, and then we'll go from there to use our graphs to find the solutions of quadratic functions, and then we'll use factoring to find solutions. So a quick review of our parent function, y equals x squared. We have our vertex, which will be the minimum or maximum point of your curve in the quadratic function. In this case, it's a minimum, and our vertex is at 0, 0. Now, looking at our function, we can see that it kind of breaks in half here along what's called the axis of symmetry, and I'll abbreviate that with AOS. Our axis of symmetry is going to be the x-coordinate of your vertex. So in this case, x is going to be equal to 0. Now we can see that we have 2 points on each side of the vertex. Our first point, if we go over 1, up 1, 1, 1, we're 1 unit away from that axis of symmetry. And then it's the same thing on the other side, 1 unit to the left from our axis of symmetry. We also have a point, if we go 2 units to the right and 4 units up from our vertex. This point at 2, 4 is 2 units away from the axis of symmetry. It's the same thing on the other side of our axis of symmetry. So it's going to be very important to remember that from the vertex, we have that pattern of going to the right 1, up 1, and then we're going to go to the right 2, up 4. So that will be our pattern for a quick and easy graph with our transformations. So if you recall transformations from Math 2, when you had all those different functions that you were graphing transformations for, remember, anything that was inside the parentheses talked about that horizontal transformation, moving to the left or right, and then anything that was added or subtracted at the end talked about the vertical shift. So for our first example, when we have y equals x minus 2 squared plus 1, then we know that our x minus 2 here indicates that we're going to go to the right 2, or the vertex will move to the right 2, and then that plus 1 at the end means that we're going to move up 1 unit. So instead of having our vertex here at 0, 0, we're going to go to the right 2, up 1, and that becomes our new vertex. Okay. Then we don't have anything going out in front of our function. It's just x minus 2 squared plus 1. So that means we get to follow the same pattern that we talked about before. So that means from our vertex at 2, 1, we're going to go to the right 1, up 1, and then to the right 2, up 4. And then remembering we have that axis of symmetry passing through the vertex, and we'll have 2 points reflecting across that axis of symmetry to create our parabola when we connect it with a curve. So there's our graph of y equals x minus 2 squared plus 1. Now, if we have an equation like number 2, we have y equals x squared plus 6x plus 5. Here we're in standard form, and it's not very easy to see what's going on. We don't know what the transformation is. So here we can use a little shortcut to find our axis of symmetry. We can use the formula. You want to make sure you write this down. X equals negative b over 2a. So keeping in mind standard form, ax plus by is equal to c, we're going to take our a value, which will be 1, and then our b value will be 6. And our c got moved over to the other side, so we have y equals. So there's our c, but we don't need it for this part of the problem. So for our axis of symmetry, we're going to say that we want our negative b value, so negative 6, over 2 times our a value of 1. Well, when we simplify all of that, we wind up with x equals negative 3. So we know our axis of symmetry is going to pass through our x-axis at negative 3. And then from there, we need to figure out where that y-coordinate is going to go. Well, if x is equal to 3, then we can take our equation, y equals x squared plus 6x plus 5, and plug in that negative 3. So if we have negative 3 squared plus 6 times negative 3 plus 5, That will give us 9 minus 18 plus 5. So our y value will be equal to a -4 when all is said and done. So that means our vertex is going to be at our x value of -3, y value -4. So we're going to come to our axis of symmetry, go down 4 units, there's our vertex. And remember, we said our a value is 1. We don't have any type of vertical stretch yet. So that means that we can follow the same pattern as before and say from the vertex we're going to go to the right 1, up 1, and then to the right 2, up 4. And then we get to reflect that over the axis of symmetry and connect our points with the curve. Alright, so 2 different ways to graph. If we see the parentheses, then that lets us know that it's showing the transformation right away. If we're in standard form, then we can use our short little formula x equals -b over 2a to find our axis of symmetry, and then substitute in our x value into the function rule and find our y value. Let's try a few more of these. For number 3, we have y equals -x plus 1 squared plus 3. So we're adding a little something here. We're going to start out the same way and say that we have that x plus 1 in parentheses. So our vertex is going to move to the left 1 unit. The plus 3 at the end lets us know we're going to move up 3 units. So we can say our vertex is at -1, 3. Our axis of symmetry passing through there. But now before we start putting our points in, we can see out front we have that negative. That negative indicates that we're going to flip or reflect over the x-axis. So this means that it's going to open down instead of open up. So instead of saying we're going over 1, up 1, we're going to go over 1, down 1. And then we'll do the same thing with over 2, we're going to go down 4. So to the right 1, down 1, and then to the right 2, down 4. And then again it's going to reflect over that axis of symmetry, and we can connect our points with that U-shaped curve. So that negative out front means that it changes the direction that it opens. It's going to open down instead of open up. But what's going to happen if we have a value other than 1 out front for our a value? Let's look at number 4. If we have 2x squared minus 12x plus 13 is equal to y. We're going to start out the same way that we did with number 2, remembering that we need our axis of symmetry. It's not, the transformation isn't given to us right away. So we're going to use that x equals -b over 2a. So we're going to substitute in our b value, which was -12. So remember the negative of -12, that makes it a positive 12. And then 2 times our a value, which was 2. So that means x is going to be equal to 12 over 4, or 3. So here's our axis of symmetry at x equals 3. And now we want to figure out where that y coordinate is going to go. So we're going to substitute our 3 in for x. So we have y equals 2 times 3 squared minus 12 times 3 plus 13. So simplifying here, we're going to save some time and just say that y is equal to -5. So that means our vertex will be at 3, -5. Alright, now this is where it's going to be a little bit different. We have that 2 out front. All this does is tell us that we have a vertical stretch by 2. So So remember we said we were originally going up 1 over 1 and then over 2 up 4. Well, that vertical stretch, we're looking at that moving up or down if it's a negative. We're going to multiply that vertical change by 2, that A value. So that means we're going to go over 1 up 2 and then over 2 up 8. So from our vertex, going over 1 up 2 and then over 2 up 8. And then we'll still reflect it over the axis of symmetry, just like we've been doing, and then connect it with that U-shaped curve. So keep in mind that A value tells us how much we stretch. Our A value is greater than 1, so it's going to be a stretch. It makes it really tall and skinny. If we have something like number 5 with an A value that's less than 1, this one's going to be a vertical compression. So we can start out the same way that we did with number 3. We don't have plus or minus anything inside those parentheses. So that means that we're staying on our, or we'll still have our axis of symmetry at x equals 0. So here's our axis of symmetry. But that minus 2 at the end means that we're going to move down 2. So our vertex is going to be at 0, negative 2. Now with that A value of 1/4, that means instead of saying we're going over 1 up 1 and then over 2 up 4, remember it's that A value that gets multiplied. So 1 times 1/4, we're going over 1 up 1/4. And then that vertical change of 4 when we multiply by 1/4, it's 1. So that means really we're going to go over 1 up 1/4 and then over 2 up 1. So over 1 up 1/4, we're barely going to see that, and then over 2 up 1 would be about there. And reflecting over the axis of symmetry, we can see that our parabola becomes very wide. So it was compressed. So A value of less than 1, it becomes a very wide parabola. A value greater than 1, you'll see it becomes very skinny. It's narrow. Alright, so switching back and forth between the two forms. We had some different forms going on with our graphs. Let's get some extra practice putting our equations in standard form. And remember, all it means to put it into standard form is that we're actually going to multiply through. So when you see that x squared, remember you're going to have to write it out and then FOIL. So we'll have f of x is equal to, in parentheses, x minus 3. And that gets multiplied by itself. It's squared, so x minus 3, and then we're going to add 4. So remembering to FOIL your first terms, that would be x squared. Your outer terms, x times negative 3 becomes negative 3x. Our inner terms, we have another negative 3x. And then our last terms, negative 3 and negative 3 is a positive 9. And then just bring down that plus 4 at the end. And then from here, we're just combining like terms. So we have f of x is equal to x squared minus 6x plus 13. So there we are in standard form. And to find our vertex and axis of symmetry, really we can get this from our original equation. So remember we said with the x minus 3, that means we're moving to the right 3. That plus 4 means we're moving up 4. There's our vertex. So our vertex is going to be at 3, 4. And then our axis of symmetry, that's the x coordinate from our vertex. So we have x is equal to 3. trying another one of those. We have f of x equals x plus 1 squared minus 3. So remember, we want to multiply it all out. F of x is going to be equal to x plus 1 squared, so it's x plus 1 again that we're multiplying by, and then subtract 3. So starting out with foiling, there's our x squared plus x plus another x plus 1, and then bring down that minus 3. And then just combining like terms, we're going to have f of x is equal to x squared plus 2x minus 2. And then looking at the original form, that plus 1 that was inside parentheses lets us know we moved to the left one. The minus 3 at the end means we moved down 3. So our vertex is located at -1, -3, with our axis of symmetry at x equals -1. Let's kick it up a notch here. We have an a value up front. So keep in mind that when we have 2 times x minus 4 squared, we're going to take care of that squaring first and then multiply by the 2. So we'll have f of x is equal to 2 times x minus 4 times our x minus 4 minus 3. So I'm going to start with foiling, which is going to give us our x squared minus 8x plus 16. Remember, there's our x squared, a negative 4x, and negative 4x. That gives us our negative 8x. And then negative 4 gives us the 16. So now that we've foiled, we want to multiply everything by 2 and then subtract the 3. So here, using our distributive property, we're going to have 2x squared minus 16x plus 32, and then subtract that 3. So all that's left to do, combine like terms there at the end. In standard form, we have f of x equals 2x squared minus 16x plus 29. And then looking back at the original, our vertex we can see is at 4, 3. That a value of 2 does not affect the vertex. And then our axis of symmetry is at x equals 4. Alright, so now that we've graphed and we've changed forms, let's solve by graphing. So if all you have is a graph, we can pick out different things from our graph. We can easily see our minimum value, the vertex, is here at 2, -4. Which means our axis of symmetry is at x equals 2. We can draw that vertical line passing through x equals 2, and points are at equal distance from that axis of symmetry. Now the x-intercepts, keep in mind we said x-intercepts, those are the solutions, or where we cross that x-axis. So looking at our graph to see where we cross the x-axis, we can see that we cross at 0, 0, and again at 4, 0. So our x-intercepts or solutions are 0, 0, and 4, 0. They may also be called the zeros. So zeros, solutions, x-axis or x-intercepts, they all mean the same thing. So now that we have those, if we want to write our equation, you might be saying, wait, we can't do that. Yes, we can. We know our vertex, and we can see that it follows the pattern of our parent function, over 1 up 1, and then over 2 up 4. So that means our a value is going to be 1. So if we think about when we are graphing given the equation, we moved to the right 2. So we have x minus 2 squared, and then down 4 from our parent function, giving us the equation y equals x minus 2 squared minus 4. So let's get some more practice finding our solutions, or the zeros, the x-intercepts, keeping in mind our parent function only has the one x-intercept at 0, 0. Now given the equation y equals x minus 3 squared minus 1, remember our vertex goes to the right 3 and then down 1. We have an a value of 1, so we can move to the right 1, up 1, to the right 2, up 4, and then don't forget your axis of symmetry here. We can simply reflect over that. Oops, let's get a better curve there. So we can see from here that we have zeros at 2, 0, and then again at 4, 0. So 2 solutions for number 10. For number 11, it's not giving us our vertex or the transformation right away. So remember, this is where we need to use our x equals negative b over 2a. So that means we have our b value of negative 4, so negative 4, it's a positive 4, over 2 times our a value of negative 1. So that means that we have our x is negative 2, so there's our axis of symmetry. And then we can plug that into y equals the negative of negative 2 squared, be very careful with that, minus 4 times the negative 2. So keep in mind we're saying negative 2 squared, and then we want the negative of that negative 2 squared. So we have negative 4, and then minus our 4 times negative 2, so plus 8. So that means our y value is at 4. So our vertex, we can say, is at negative 2, 4. And I put my axis of symmetry on the wrong side. Sorry about that. We'll fix that. We want to go to negative 2. So negative 2, 4. Here we go. We'll draw. And then keep in mind that a was negative, so it flips and it opens down. So a value is still 1, it's just a negative 1, so that means we're going to go to the right 1, down 1 following that parent function, and then to the right 2, down 4. Reflect over the axis of symmetry and draw your curve. So we can see our zeros here, or the solutions, are at negative 4, 0 and at 0, 0. So another 2 solutions for that one. We'll try a few more and then we'll talk about factoring and how that's used to solve. So looking at number 12, we have y equals negative 3 times x plus 4 squared plus 3. So we can see that we're going to go to the left 4 and up 3. So 1, 2, 3, 4. There is our axis of symmetry. And then going up 3, there's our vertex. Now be very careful because we have negative 3 as our a value. So this means that we're going to open down, but we also have that vertical stretch by 3. So here, instead of over 1, down 1, and then over 2, down 4, keep in mind that has to be multiplied by 3. So we're going to go over 1, down 3, and then over 2, down 12. So when we plot those points from our vertex, over 1, down 3, we can see we hit the x-axis, over 2, down 12, that's 4, 5, 6, 7, 8, 9. Oh, we're going to go way off the grid. We're down here somewhere. And then we reflect over our axis of symmetry. We'll be down there, kind of estimating. And we can see that our x-intercepts, or the solutions, are at -5, 0, and then -3, 0. For number 13, we have y equals 2x squared minus 4x. So again, we're going to get some more practice using our little formula for axis of symmetry, where x equals -b over 2a. So that means we have our negative b value of -4, so positive 4 over 2 times our a value of 2. That becomes 4 over 4, which is simply 1. And then if we say that y is equal to our 2 times our x value of 1 squared minus 4 times our x value of 1, then we'll wind up with a y value of -2. So that means our vertex is at 1, -2. So we'll start drawing our axis of symmetry at x equals a positive 1. And then we'll put our vertex at 1, -2. And then with that a value of 2, that means that we have a vertical stretch by 2. So instead of over 1 up 1, we're going to go 2. 1 times 2 is 2. And then instead of over 2 up 4, 4 times 2, that's going to give us 8. So from our vertex, over 1 up 2, and then over 2 up 2, 3, 4, 5, 6, 7, all the way up to the top. And then just reflect over your axis of symmetry. So there's our parabola. And we can see our solutions, or zeros, are at 0, 0, and 2, 0. Let's look at one last graph and find those solutions. For number 14, if we have y equals 1/2 times x minus 5 squared minus 2. So we're going to go to the right 5, down 2. So to the right 5, there's our axis of symmetry. And then down 2, here's our vertex. And then with that a value of 1/2, it's going to be very short. Remember, a value of less than 1, less than 1, is going to make it much wider. So we're going to go over 1 up 1/2. 1 times 1/2 is 1/2. And then over 2, instead of up 4, 4 times 1/2 is 2. So we're going to go over 2 up 2. So from here, over 1 up 1/2. And then over 2, we'll pretend our graph extends out that far, and go up 2. And then reflecting over our y-axis, or the axis of symmetry, we can see that we have solutions at 3, 0, and 7, 0. So it's very easy to see our solutions, or the x-intercepts, from the graph. But what if we don't have the graph? Well, we can also solve by factoring. So if you think back to your review, factoring, breaking it down, if we have x squared minus 2x minus 15 equals 0. When we're in standard form, use your a, b, and c values to break things down. We have an a value of 1, so that means that our factors are going to be x and x. So now we're going to look at factors of -15 that give us a sum of -2. Well, if we think about 5 times 3 gives us 15, I want a -2 in the middle, and since it was a -15, one has to be positive and one has to be negative. I want a -2, so that larger one is going to have to be with the negative. So we have x plus 3 times x minus 5 is equal to 0. And you should always do a quick check with FOIL and make sure that it does work back correctly. Now, to come up with the solutions, all we're going to do is break it down and say that x plus 3 is equal to 0 and set our other factor x minus 5 equal to 0. And then we just solve those two quick equations. So we have x is negative 3, and then x is 5. Quick check, you can always substitute back in to make sure that they work. Negative 3 squared is 9, minus 2 times 3 is 6. So 9 plus 6 is 15, minus 15, yes, we get 0. That one checks out. Same thing with 5, that would give us 5 squared, minus 10. Well, 25 minus 10, that gives us 15, and 15 minus 15 is 0. So both of those solutions work. Always, always, always check your answers. All right, something like number 16, if we have z squared minus 5z equals 0, only have two terms and both of them contain a z, so we can factor out that z and then we're left with z minus 5 equals 0. There's nothing else to do there, so we're going to set each factor equal to 0. So remember that z that was out front, the z that we took out, is set equal to 0. We also have z minus 5 equals 0. So all we have to do here is say, well, if z minus 5 is 0, then z equals 5. So that means our solutions are z equals 0 and z equals 5. Do just a couple more, and then I'll let you try some on your own and do some homework. So for this next one, if we have x squared plus 6x equals negative 9, we want to get into standard form first. That means we're going to add the 9 to both sides. And that leaves us with x squared plus 6x plus 9 is equal to 0. Again, we have that a value of 1. So that lets us know that when we go to factor, that first term will be just a plain old x. And then we're looking for factors of positive 9 that give us a sum of positive 6. That means everything will be positive. The only way we can get 9 is either 1 times 9 or 3 times 3. Well, we know that 3 and 3 give us a sum of 6. Quick check of FOIL. Yes, there's our x squared, 3x, and 3x gives us 6x. And then 3 times 3 is 9. So we factored correctly. Now just set each of those factors equal to 0. And that leaves us with x equals negative 3 for both of them. So we would just say that x is equal to negative 3. All right, one last example. We have 3q squared minus 7q equals 20. We're not in standard form, so that's the first thing that we want to do. Bring that 20 over to the other side. So 3q squared minus 7q minus 20 equals 0. Now I notice that I have an a term of 3, so I want to see, is there a common factor that I can take out of 3, 7, and 20? Well, no, 3 is prime, 7 is prime, that's not going to work. So that means that when I go to factor, one of those will be a 3q, while the other one is just 1q. So now I need factors of negative 20. Well, factors of negative 20, I first think of 5 and 4, so we can try that. So we want a 5 and a 4 in there, and it's negative, so one needs to be positive and one needs to be negative. So let's do a quick check with FOIL and see if we have the original function. There's our 3q squared, a negative 12q plus 5q, that does give us a negative 7q, and then 5 times negative 4 gives us negative 20. So I did factor correctly. If you go to check with FOIL and it doesn't work, it's okay, that's why we use pencil, just to erase it. It might be you need to switch the signs, you might need to switch factors, but keep checking with FOIL until you get it to work. We got it to work, so that means that we're just going to set our 3q plus 5 equal to 0, and then our q minus 4 equal to 0. And then solving each of those, if 3q equals negative 5, then that means that q is equal to negative 5/3, and you can have a fraction, that's okay. And then on the other side, when we just add 4 to both sides, we have q equals 4. And again, be checking, take your solutions, substitute them back in, and make sure that they do work. All right, you have plenty of extra practice to try in your packets. Remember to check your answers to the homework on Blackboard. You can email any questions or send me a message through Remind, and I will see you in class.